What's up, Coder Byte? Welcome back to another data structures and algorithms video. I'm Elizabeth, and today we are going to be doing what I would call a medium problem involving our good old friend stacks. We are going to be able to leverage stacks to get this algorithm down to a big O of n. And without further ado, let's get into this week's problem. This week's problem is called next greatest number. So let's find out what that actual question is. The next greatest integer of some integer is the first greater element that is to the right of the integer in the same array. Warning in advance, the English for this question makes little to no sense. If you don't understand a word I'm saying, wait till my visualization because it took me a really long time to wrap my head around what this question was even asking. You are given two distinct arrays, nums1 and nums2, where nums1 is a subset of nums2. So every single element in nums1 does appear in nums2. That's all that means. For each integer in nums1, find the index in nums2 such that nums1 at I equals nums2 at j. So basically, for every integer in nums1, find that integer in nums2. And determine the next greater element of nums2 at j in nums2. So after you find the matching element in nums2 that you're looking at in nums1, find the next greater element in nums2 that comes after the number you found that you're looking at from nums1. Again, if you're not following, don't worry about it. If there is no next greater element, then the answer for this query is -1. Finally, return an array of length nums1.length such that the return array at each index is the next greater element of nums1 at I as described above. So let's look at an example and clarify all the things. So here we have our nums1 array with some integers in it, and here we have our nums2 array with some more integers in it. And so what are we expecting? So we're returning an array, and this array is going to be of length equal to nums1.length. So this return array is going to be of length 4. So the first thing we're going to do is we're going to look at each integer that is in nums1. So let's look at 4. The second thing we're going to do is find that integer in nums2. There it is. Then we're going to look at every element that comes after it until we find an element that is greater than 4. So we look at 8. 8 is greater than 4. We're going to push that onto our return array because 8 is the next greater element to 4. Then we're going to look at 3. We're going to find 3 in our second array. We're going to look at 2. Is 2 greater than 3? No, it is not. So we're going to continue looking. 4 is greater than 3, so that is the next greater element to 3. We're going to push 4 onto our return array, and so on. 6, we find 6. 5 is not greater than 6. 10 is greater than 6, so we push 10. And then finally, we look at 10. We find 10 in our second array. 3 is not greater, 2 is not greater, 4 is not greater, 8 is not greater. So the answer to this query is going to be -1. So I think it's actually a very simple problem without the English. So what's the naive approach? And like always, we are going to go through the naive approach because I do think that it is useful in determining how you are going to build your optimized approach. So the first thing we're going to do is loop through nums1. Loop through nums2 to find the matching integer. So that's the step where you get an integer from nums1 and you find it in nums2. After finding the matching int, loop through each integer following the matching int and find the first int greater than the int we are looking at. Finally, add it to the return array. So pretty simple. We're going to code this out, although I'm sure you can all do it with your eyes closed at this point. But let's code. Okay, let's code out this naive solution. So first we're going to start with our function, and I think I'm going to call it next greater element naive. That works, and we're going to get a nums1 and a nums2. Okay, and then let's just write some testing code. We're going to say next greater element naive, and then I'm just going to pass in the example from the slides. Easy peasy. And remember, we are expecting to get 8, 4, 10, and -1. Okay, let's do our comment block. So nums1, this is an array. An array of integers that is a subset of nums2, an array of integers. And then this is going to find the next greater element in nums2 for each corresponding int in nums1. And let's do a return, and this is going to be an array. We're going to return an array, and this is going to be array of next greater integers. Okay, easy. Okay, so first let's define our return array. And then we're going to loop through nums1, and then we're going to loop through all of the things that come after that number in nums2. We're going to compare whether or not the number in nums2 is greater than the number in nums1. And if it is, we're going to push it to our array. If it's not, we never find one, it's going to be -1. So let's start our loop. So let's say let I equal 0, I is less than nums1.length, I plus plus. And then we have to start our nested loop at the index that we find the integer in nums1 that we're looking for. So in order to do that, we're just going to use the array find index method, which is super simple. So let's say let nums2 index equal nums2.find index, and this takes a callback. It's going to get an element. We're basically just going to compare L equals nums1 at I. So that should give us our index in nums2 that we find the integer that we are looking at in nums1. So let's define our second loop. Let's say let j equals nums2 index plus 1. And remember, we're only looking for the elements after it because we're only looking at the next greatest integer. We're going to say j is less than nums2.length, j plus plus. And then we're just going to check, right, if nums at j is greater than nums1, if nums2 at j is greater than nums1 at I, we're going to push it to red, nums2 at j. Now, the only problem is here is, well, first of all, we don't have to continue our iteration, right, if we've found our next greatest element, so we can break out of this. The only issue with this code is we don't know if we've reached the end of j. We only know that we've reached the end of j here, right? But we don't know if we've actually pushed anything to our array in the interim. So I'm going to initialize a variable called found, and it's going to be false, and that's going to reset every time this loop's finished. And then here, we are going to set found equal to true if we found something. And then if found is still false, we're going to push to our array -1. And I think that's it. So let's see here. Return red. And let's see what we get. Can't find module next greatest number. Easy fix. Okay, so what is going on here? So this is on the wrong line, right? So we don't want to push -1 every single time this doesn't work. We want to push -1 after this completes. So I had that on the wrong line. Let's try that one more time. And we get 8, 4, 10, and -1, which is exactly what we expected. So obviously this solution is less than ideal. Let's talk about that optimized solution. So let's talk about our optimized approach. So with our optimized approach, we're going to leverage the stack data structure. And by doing this, we're going to reduce our time complexity significantly. So what are the steps to this? So first, we're going to initialize our stack and a map. And you'll see why and how we use these in a second. So here's our stack and here's our map. For each num in nums2, so here's our nums2, and already this is deviating from our naive approach because instead of looping through nums1, we're already skipping straight to nums2. We're going to, while there are integers in the stack, and all of this will get clearer when we actually walk through this example with this new approach. So while there are ints in the stack, and the last element in the stack is less than the int we are looking at, we are going to do two things. We're going to add a mapping between the last int in the stack to num, and then we're going to pop the last element off the stack. So in this way, let's say we're looking at 6. We have 6 on the stack. Then we're looking at 5, and we have 5 on the stack. And then finally we look at 10, which is our first element that is greater than the last thing on the stack, which is 5. We're going to add a mapping to our map that 5's next greatest element is 10. Then we're gonna, because we still have elements in our stack, right? 6 was added to our stack previously. We're going to add a mapping of 6 to 10, where 6's next greatest element is 10. And finally, our stack is reduced to 0 and we stop this while loop, right? This while loop. So what does this accomplish? In this way, we are building a mapping for every element in this array to its next greatest integer. So we're doing work that we don't need to do because let's say, I don't remember the example what nums1 was, but let's say 5 was not passed in. We don't care that 5's next greatest element is 10. But because we're building this mapping, we can then loop through nums1 and just do a lookup. If it's in nums1, is there a mapping in nums2 for that integer to its next greatest integer? And in that way, we only have to loop through each array twice. So we can drastically reduce our time complexity to a big O of n, because despite the fact that we're doing it twice, those loops are on the same level. So we can drop the constant of 2 and return that big O of n. So let's continue with our approach. So we do the while loop, we add the mappings, we pop the last element off the stack, and then finally, when our stack is back to 0, we push num to the stack. So in this example that I just said quickly, we push 6 to the stack. 5 is not greater than 6, so we just push 5 to the stack. We finally get to 10. 10 is greater than 5. We add the mapping. 10 is also greater than 6, so we add the mapping. Our stack is now 0. We push 10 to the stack. So the next time we iterate, we're going to be looking for if 10 has a next greatest number. So let's watch a visualization here. So first we look at 6. We add it to the stack because there are no ints in the stack, and the last element in the stack is, well, there are no elements in the stack. That's the important piece here. There is no last element in the stack to compare it to. So we add 6 to the stack. We then move on. Num is now 5. So there are ints in the stack, but the last element in the stack is not less than the element we're looking at. So what do? We push the number to the stack. Then we look at 10. So finally, 10, there are ints in the stack, and the last element in the stack is less than the int we're looking at. 5 is the last element in the stack, right? So 5 is less than 10. So what do? We add a mapping between the last int in the stack to num. So we're going to add a mapping from 5 to 10 because 5's next greatest integer is 10. And then we're going to pop that last element off the stack because we found that already. Now this while loop is still going to continue because there are ints in the stack and the last element in the stack is still less than the int we're looking at. So now we still have 10 as our num, we're looking at 6. 6 is less than 10, so we add our mapping to our map between 6 and 10, and we pop that off the stack. And finally, after this while loop finishes, we push num to the stack. So now 10 has not been looked at in terms of its next greatest integer, so that gets pushed to the stack. And we continue. Now we look at 3. 3 is not greater than 10, so we push it to the stack, right? Okay, then we look at 2. 2 is not greater than 3, so we push it to the stack. 4 is greater than 2, and there are numbers in the stack. So what happens when 4 is greater than the last element in the stack? We make a mapping. So now we make a mapping between 2 and 4, and we pop 2 off the stack. 4 is also greater than 3. So what do? We create a mapping from 3 to 4. 3 gets popped off the stack. 4 is not greater than 10, right? So this condition doesn't get fulfilled. And all we do is push number to the stack. So now we push 4 to the stack. Then we do 8. 8 is greater than 4. So what do you think we do? We create a mapping. 4 gets popped off the stack. 8 is not greater than 10. So our while loop condition is not fulfilled, and we push 8 to the stack. And that's our final result here. So we get this map. And ultimately, when we loop through nums1, we'll just look for each of those numbers in this map. And if it has a mapping, we just return whatever it maps to. If it doesn't have a mapping, we return -1, right? 10 never made it into this mapping as like 10 to a greater number. So when we do that lookup, it will fail and we'll just return -1. So this is kind of just explaining what I already said, but this map serves as a directory of all of the ints in nums2 and their corresponding next greatest int. And after we build our map, we can loop through nums1 and see if the int exists in our map. If it does, we can just add its corresponding next greatest int to our return array. And here we have our nums1. Here's our map. So we look at 4. 4's mapping is to 8, so we add 8. 3, 3's is to 4, we add 4. 6 is to 10, so we add 10. And 10 doesn't have one, so we add -1. And, just to reiterate why this stack approach works is every single time we look through our elements in nums2, we leave things on the stack that haven't yet found their next greatest integer. And then we work backwards from the stack, right? A stack is a data structure where first in is last out. So we work backwards. And when we're at a number, let's say 10, and there are multiple numbers before it that are less than 10, each of them needs to map to 10. And if one of the numbers that came before 10 already had a greater number, it wouldn't be on the stack. So I hope that's clear. We're going to code this out. I really thought this was a really neat solution, and one I wouldn't have necessarily thought of right off the bat, but it's a great way to use a stack, and it's a fun problem to code out. So let's do it. All right, so let's attempt to code out this optimized solution. So let's call this function next greater element. And this is, oh, no, we don't want that. We also want to call it a function. And this is going to take a nums1 and a nums2. And let's change this to call the correct function. And let's, right, and this is actually just going to be the same as this. So I'm going to copy it because I'm lazy. Okay, so what do we have to do here, right? So first we have to write init our stack and our map. Very simple. So let's say let stack equal array, and then let map equal new map. All right, so that's simple. And now we are going to create our logic to loop over nums2 and create mappings from each L to its next greater num, right? All right, so that's, again, simple enough. So we're going to say let num of nums2. And then what do we have to do? So remember what that condition was. So while there are elements in the stack, and num is greater than the last element in the stack, right? So that's where we're going to do our logic for building our mapping. So let's say while stack.length and stack at stack.length -1, so the last element in the stack is less than num. This means that we are going to create our mapping, and then we're going to pop that last element off the stack, which we can do all in one line. So we're going to say map.set stack.pop, so that will remove that last element from the stack, and we are going to set the mapping to be to num. So num here is the next greatest integer in nums2, and the last thing on the stack is the number that came before it. And this loop is going to continue until either there's nothing left in the stack, or the last thing in the stack is not less than the number we're looking at. All right, so that's simple enough. And then after that happens, we are always going to stack.push num. So let's leave it at that, and let's see what this mapping looks like. So I am going to console.log our map. And let's see what we get here. So here we have our map, and here is our example here. And let's see, so 5's next is 10, its next greatest element or integer. 6 next is also 10. Let's see what happens next. 2's next is 4. 3's next is also 4, and 4's next is 8. And I want you to notice here that 5 to 10 comes before 6 to 10, because again, a stack is going to be first in, last out. So 6 goes in the stack before 5, so the first thing we're looking at is 5. So that's really, really simple, right? I think the kind of conception of this problem is a lot harder than the implementation. So now finally all we have to do is loop through nums1 and find its mapping in the map. So again, easy enough. For let I equal 0, I is less than nums1 dot length, I plus plus. And then we're simply going to say that we didn't define a return array. So let's do that real quick. Let ret equal that. And we're going to say ret.push. Let's see. We're going to say let next greater num equal map dot, what do we want to do? Yeah, we want to do that. Map dot has nums1 at I. So if it has the nums1 at I, we want to set the next greater num to map dot get nums1 at I. Or, right, -1. Why is that not working? So map.has, right? So that we've map.get. This is the wrong place for our paren. Okay, so the next greatest num is either going to be whatever is at that map, if it has it, and if it doesn't have it, we're just going to set that equal to -1. And then we're going to push that to our return array, next greater num, and then we're going to return our return array. And let's see what we get here. Did I remove the console log? Yeah. So we get 8, 4, 10, and -1. Beautiful. Okay, so we've kind of discussed this already, but let's explicitly talk about the big O of this optimized solution. So this function implementation has a big O of n. So why is that? So we loop through nums2 to build our map, which is O of n. We then loop through nums1 and do a lookup on our map, which is also O of n. And because we do an O of n operation twice, that would be 2 O of n, we can drop the constant and we are still left with a big O of n, which is excellent. All right, there you have it. That's this week's problem. I hope you all enjoyed, and I am definitely going to link to our stacks or previous stacks videos we've made in the past. And I hope you all have a good week. See you in the next one.